Imagine this. You're in the kitchen, whisking eggs, heating oil in a pan, watching ingredients transform before your eyes. But what if I told you that every meal you cook is actually a chemistry experiment in disguise? Cooking isn't just about making food. It's about understanding how heat, molecules, and reactions come together to create something delicious. Let's step into the science behind cooking, because every recipe is really a formula, and every bite is a lesson in chemistry. Cooking involves heat, molecular interactions, and chemical transformations, just like a chemistry lab. When you cook, you change ingredients at the molecular level, transforming raw materials into something new. Let's take a simple dish, an omelet. Seems easy, right? But beneath the surface, a whole world of chemistry is at work. When heat is applied, the proteins link together and solidify, forming the structure of the omelet. This process is called coagulation. It's why raw eggs turn from liquid to solid when cooked. Raw eggs contain tightly folded proteins. When you whisk them, you introduce air and start to unfold these protein structures. This is called denaturation, where proteins lose their original shape and become more flexible. That delicious golden color? It's caused by the Maillard reaction, a reaction between proteins and sugars when exposed to heat. This reaction is responsible for the browning of meat, toast, and even roasted coffee beans. When you add cheese, heat breaks down fat molecules, causing them to become soft and gooey. This is a phase change similar to how ice melts into water. Cooking involves chemistry in many ways. Let's look at some more examples. Baking bread. Yeast produces carbon dioxide, making dough rise. Boiling pasta. Starches absorb water and swell. Making whipped cream. Air bubbles get trapped in fat, creating a fluffy texture. Caramelizing onions. Heat breaks down sugars into new, flavorful compounds. Understanding food chemistry helps reinforce key chemistry concepts found on the New York Regents Chemistry Exam, including phase changes, solid, liquid, gas, chemical versus physical changes, melting versus burning food, acid-base reactions, like using baking soda to neutralize acidity in recipes. Cooking isn't just about making meals. It's a real-world application of chemistry. The same reactions that happen in a lab occur right in your kitchen. Have students choose a recipe and analyze the science behind it. Encourage them to answer these key questions. Which steps in the recipe show physical or chemical changes? Which steps are endothermic or exothermic? How do intermolecular forces change throughout the recipe? This activity helps students apply chemistry concepts to real-world scenarios, reinforcing key topics in a hands-on, engaging way. After carefully analyzing a recipe and understanding the scientific concepts behind it, it's time for students to present their findings in a creative way. In your creative project, have students justify why they chose their recipe. Have them address these key scientific concepts, physical properties. How do texture, color, and consistency change during the cooking process? Intermolecular forces. What happens to the molecules as they interact during cooking? Chemical or physical changes? Are the changes chemical or physical, and why? Energetics. Does the recipe involve energy absorption or release? Let your students' creativity shine. Whether it's a drawing, a song, or a TikTok video, make sure they highlight the science behind their recipe. Explain the physical and chemical changes, intermolecular forces, and the energetics in an engaging, fun, and educational way.